So we'll plot the points. So let me just transfer them here. So 1, 4, 2, 16, 3, 64, 4, 2, 56. Okay. Okay, so, 1, 4 is like, whee, so what is that? That's 20, this is 10. So here, 2, 6, oh wait, this is 1. Don't do that. Here we go. Sorry guys, this is 1. 2, 16, 3, 64, 2, 56. All right, and don't connect the dots, so don't do this one. That was a oopsie. It's right there, right? Those are your 4 dots. Okay, this is your step. These are your total boxes, right? Okay, an exponential function. We don't have a shift yet, so we're just gonna stick with the basics. You're not in im3, so we'll stay with that. Okay, a to the x. A is your rate of change. Okay, that's your base. That is your rate of change. And exponential functions are multiplication or division. Okay, so what's occurring here is you're either multiplying by either an integer, or it could be a fraction, but a lot of students see the fraction and you guys think that you're dividing, right? Like, because if you're multiplying by 1/2, 1/2, 1/2, 1/2 is 1/2, like the 2 is a denominator. So some of you will then say, oh, we're dividing by 2, and then a student will say we're multiplying by 1/2. It's the same mathematically, right? It's the same, right? Yeah. Where's my two little circles?
Right there at the bottom where it says rate of change, what are the 2 little circles?
Oh, of, OV?
Oh,
okay. OV, yeah. I was like, I don't know. Yeah, there you go. Okay, so now, so here again, because eventually you're gonna work with a lot of tables. Like always, as you move from cell to cell, what's occurring? You're multiplying by 4, multiplying by 4, multiplying by 4. So this is a multiplication, and so when it's a multiplication, that's when you know it's exponential. When you're adding and subtracting linear, exponential, you're multiplying, dividing. Okay. All right, how do you write recursive and explicit? Remember, recursive, you need 2 terms. Initial term, and this is the one students like to forget, and it's the easiest one because it's the very first term. F of 1 is equal to 4. It's like so easy. You guys just, you get so wrapped up in general and figuring it out that you just forget to write initial. And so that one was what you wrote up here. This. Okay, so either one. So f of n is the prior term, and then what's the constant change that's occurring? You're multiplying by 4. And so that's your recursive. Oh wait, before I go into explicit. Okay, so explicit, if we're on an exponential pattern, and from cell to cell, or from step to step, as it grows, you are multiplying by a 4 integer. That is my a value. And so it is y equal 4 to the x. Or f of n is equal to 4 to the n. Or you can put f of x is equal to 4 to the x. But that is your recursive function. So So if you were multiplying by 1/2, it would be 1/2 to the x. If you were multiplying by 1/2, it would be 1/2 to the n. So not bad. And so I'll give you guys your quizzes first, and then I'll pass out the packets, and then I'll give you guys credit for your linear exponential. Fair? And then if you have another assignment to give you from last week because you added or whatever, I'll get that from you too. All right. And then the Canvas will start loading up. The reason why my im3 classes, they got taken care of by the office, because what happens is, since I'm a math class, I have collab teachers, and so I'll have students on one tile and another tile. And so if I try and put anything in, if I try and put something in and then they decide to then make it one tile, the data disappears. So I would kind of wait for the office to combine the students on Aries, and once they do the combination on Aries, then I could do it on Canvas and none of my data is gonna leave. So they did it yesterday, like morning, they took care of it. Okay, so you guys will start getting your grades updated with your quiz and everything, okay? Okay, let me turn this off.